Well, hello everyone. Welcome to our first webinar event. My name is Paula. I'll be your host today. And I'm co-founder of LinkedAI, a startup that specializes in training data generation for computer vision applications. Today we have a fantastic lineup of speakers who will be sharing their expertise and insights with us. We have invited these experts in computer vision and in different applications to celebrate the official launch of our new website at LinkedAI. So we are very excited for today, and we are very excited to welcome our speakers. Um, our first speaker is David Cardoso. He's a top leader in the field of AI with an extensive background in data science and machine learning. He has worked in many different companies in the industry as machine learning engineer. He is a machine learning Google expert as well, and I'm very excited for this talk. I promise it's gonna be very interesting. So welcome, David.
Hello, everyone. Hello, everyone. One thing that mentioned is that Paula and I were co-workers before, so I'm really excited to have this kind of opportunity to be able to share the stage again. So I'm here to talk about a little bit of what we have been doing in the JAX ecosystem. And yeah, so I'm a tech lead for Updata, a company in Canada, in Quebec. And if you need help for putting machine learning in production and you are in the industry, agro, or production side, we are Google partners in that sense. So today I'm going to talk about JAX. So thank you, Paula, for the stage.
Sure, David, welcome. I'm very excited as well. I'm very happy to have you here. And
Yeah.
yeah, you can take it from here.
All right. So hopefully we are going to put my screen on the stage. All right. So as I mentioned it, my name is David Cardoso. I work out of Data. We are a consulting company for machine learning in Quebec, Canada, and Montreal. And I'm going to talk about a little bit of the tools that we use a lot in this environment. What are challenges and how this kind of technology empowers you to use like object detections, deep learning, and how it's important to have a really good partner into the data labeling part. So I don't see if my screen is being shared. So if that's perfect, thank you very much. So that's it. A little bit, I'm going to, hopefully it's going to work. So if we go back a little bit, we're going to see that things in machine learning move quite fast. And in the sense that at some point, I personally, I have felt that sometimes you learn technology A, and then somehow technology B comes in, and then someone told you like literally 5 minutes ago, you need to learn this, and then before that. So as an example, I was always very fond of recurrent neural networks. Then somehow transformers got into the play first in the NLP environment, and then afterwards the vision side, which is going to be an important study for us. And somehow it feels like this, like you need to start learning this. Then 5 minutes later, 5 minutes later. I'm going to put a little bit, yeah. Then 5 minutes later, you need to learn transformers, attention mechanism. And sometimes I really hope that hey, why can't you tell me what is going to be hot in the next 6 months? And then it doesn't know. So of course, I'm going to talk about another framework, another machine learning framework. But keep in mind that every few months there is a new framework, there is a new thing. But I want you to understand what are the limitations of these kind of frameworks and what they are trying to solve. And always, it's important is which tool is best to use in your case scenario. So Jackson Flags, PyTorch, TensorFlow are all examples of machine learning frameworks. So as a joke, I wanted to put like, are we becoming like the new JavaScript, in which every single day there is a new set of frameworks? There is JAX, there is TensorFlow, there is MXNet, a project made by AWS, there is NVIDIA Digits, there is Flax, there is Chainer, and somehow it feels there is a lot of things that to solve one problem, which is object detection, or how to do image recognition, or how to let the computers figure it out. So I want you to take into account that all these kind of frameworks, all these kind of technologies do exist to solve one of there are two things that are difficult in computer science. First is cache invalidation. The second one is naming thing. The third one is asynchronous callbacks, and the other one is off by one errors. So recall these kind of all things, or all these kind of frameworks are always there to solve one specific problem. It's how to manage the state, how to set, okay, these are my parameters, I want to change it by application of a gradient descent algorithm, how we can actually do that. And all these kind of frameworks, I want you to take this kind of view in which it's important how to manage state and how to run this kind of these progress and algorithms. So every time that you see something like that, the important thing is how to manage state. So you could pose the question as, how difficult is this actually? I mean, I give you a function f, I give you an algorithm, I give a gradient descent algorithm. How difficult can I put it? I need to evaluate the function f, hopefully in a very fast way. I need to get the gradient and the derivative of f, which should be also very, very easy. How to evaluate f at one point, because I want to evaluate not only at that point, but in a batch of points. How can I make it fast, and how can I make f like batch this kind of function very intensely? So I put the question to myself: is that I'm out of touch? Is that something that it should really require 6, 7, 8, 11 machine learning networks to solve? And I think no, actually, it's the machine learning engineers that have it wrong. So let's see how JAX and Flax how solve these kind of problems, and see what it's becoming important to tackle this kind of problem each independently. So as I told you, JAX is an open source framework. It's been developed by Google. It's very suited a lot for research work at the moment, but there is a whole ecosystem that is being developed for putting this kind of machine learning models into production. Because as you're going to see and you're going to walk through me, it's very easy. It's very expressive to put different complex architecture into code and being able to have this kind of all the things that we wanted is get a fast way to get the gradients, get a simple way to optimize parameters, and how to run these kind of things extremely fast. So JAX is the combination of mostly three things. So autograd, and autograd, it's the procedure, or in computer science, is get to know the process of taking a function and give me the derivative, give me the gradients. How if the question that we're always trying to solve in mathematics with this is that how a function change if I just modify a little bit of the input, right? And we are going to have is that as soon as we change a little bit of these inputs, how that change into our loss parameter. So autograd is this complete field that tries to respond to that question, how to do this fast and easy. And XLA, so as you know, Python is interpreted. So Python as an interpreted language is going to have a little bit of cost on running algorithms. So what we're going to do is that we're going to compile Python code. We're going to read Python code and then dispatch a very fast operation that can run in any accelerator via GPU, via a TPU. And the important thing is that we know that it's very difficult to learn another thing, learn a new language, learn a new stuff. And what we want to have is that if you already know NumPy, which probably is the first library that you learn in your machine learning or data science career, that you can easily, or just without changing your mental state, you can run JAX. So you will imagine that this is very fairly new, but I wanted to show you that it's actually not. So for those that are following the ChatGPT stuff, the large models, the content ChatGPT that is being used in Google Workspace, that is used also in Gmail, and everything is one large AI that is called Palm. Palm is a large language model being developed by Google that was actually done in JAX and Flax. So it can do many things that ChatGPT can also do: semantic parsing, question answering, do mathematics, do language. So it's one of the tools that you actually interact a lot, and it's a JAX model that is being run on production. You also have, I don't know if from the audience that you guys use Google Lens. So when you take a screenshot and you want to say, okay, can I get these photos of these sneakers, or can I identify exactly where that text come from, where the boundaries of those texts, what are the important elements of a mobile UI. Google Lens use a deployed model of JAX that actually so takes a screenshot and try to interpret it, what are the types and the object types in the screenshot. And one shot, and also it's in Google Lens, you have one shot detection. So sometimes even Google cannot not know what are the new categories, what are the new things. So if you're, I'm going to share the paper at the end, but this kind of one-shot detection in which you train a large model, very general settings, and you just give an example of a new category, and you want to be able to identify this. This actually is run. It's a model that was compiled in JAX and being deployed to multiple million of devices over the world. So if you're interested in these kind of things, which is my area of expertise, I know that everyone is explicitly very enthusiastic about ChatGPT, but I want you to give you the sense that every progress in different fields can affect the other ones. So in the case of transformers, was a technology developed by the NLP world. It went to the vision world after 2-3 months, and it enabled this kind of amazing things that happen. So it's always important that in machine learning, I think that specialization is incorrect. Having a general overview of what is the development of new areas, it can help. It can help it to give you insight into your kind of problems that you could see on the area. So let us go a little bit more technical. So you're going to see that instead of having a numpy array, we're going to have a JAX device array. So what device array is going to have is going to be the core array JAX object. All right. It's going to follow lazy evaluation. So that being said is that you can queue a lot of operations that as soon as you need the result, is going to try to compute it. So you're going to have an speed up on the optimization of execution, and it's extremely very similar to a numpy ND array in NumPy. So the only thing that you're not going to have is that you can do in-place updates. All right. So we're going to see that same API. You can have the min, the max. You can also even bring operations that you know from the NumPy world to the JAX world. So if you want to do the dot operation, the dot similarity between two elements, you're going to see that you can also do it with the NumPy API provided by JAX. So important thing, or the thing that I want you to take for that, is that if you already know NumPy, you're going to see that it's very easily to change this code, your existing code into JAX. And not only you will be able to get an upgrade for free, because the device array is going to be able to run either in GPUs, in TPUs, or any accelerator that is possible. And you're going to see that if you do the comparison between dot from the NumPy library and the dot from the JAX NumPy API, you're going to see a quite significant improvement of the speed of the algorithms. All right, so things that are the only difference is that you cannot do you cannot mutate your arrays in place. You're going to need a very important operator that is going to be the set, and that's probably one of the biggest kinks when you start to get to JAX. So just set it, and you're going to see that eventually this kind of codes that it looks like it's making a copy or returning a copy, when you give it or when you compile it, JAX is going to be very smart and just do the operation in place. So things like when you're computing an NMS in an object detection, you're going to see that these kind of things, when you JIT it, you're going to get a significant speed up. All right. Now, oops. The also important thing to be able to get this kind of speed ups is also that we need to change that from our object-oriented approach that function should be pure. What does it mean that a function be pure? And this is a concept for computer science, is that functions should only depend on their inputs. There should be no global state. There should be no things in the global context that change that change the behavior of a function. And that's going to be important because as soon as you have that constraint, you're going to be able to have functions that are being easily, you can parallelize very easily. You can also do optimizations given the fact that there is nothing else that is changing the value of your parameters. And also, you can also do optimizations depending on the type, on the signature of the function. So as the same in Julia, if you have any experience with Julia, as soon as you give something like X, could be an array, a vector, it's going to be you're going to find that the compile function is extremely fast. So pure functions, as I mentioned, are very easy to debug because you can just take, it's like a small component, you take it and you run it someone else. You can easily parallelize this thing because observe, if I have an operation that it's A plus B plus C, and I know that there is no interconnection between them, that there is no global state that changes, I can dispatch A to an accelerator. I can dispatch B in another accelerator. I can dispatch C to another accelerator. Then I do the aggregation. And I know because there is no global state that there is no shared state that I can actually get a result from that. That also allows us that since there is no side state, we can do caching. So if we already compute a function for a certain type of input, we can cache that result or we can cache that function. We can also do composition and function and keep the transformations that if something doesn't share state, you can also do a composition, and the composition of functions that are pure, it's pure. So we're going to see. Also, we have preferential transparency. This is going to be a little bit more advanced, but that is that whenever you see A equals B, that means that you can also change it, B equals A in any part of your algorithm, and it will still make sense. So that's it. So there is a question that if JAX can directly run on GPU, CPU, does it mean that we don't need to wrap the device array around Tensor when using the TensorFlow unlike NumPy array? Exactly. So the important thing, as I told you, as we told at the beginning of this presentation, is the most difficult things in computer science is to manage the state. So if we can let out of that sense, if we can abstract whatever in whichever hardware we have, our algorithms are going to be much easily to debug. So compare that in PyTorch when you have to do device 2 and then send it to CPU, GPU. We're going to completely forget about that and let the computer, which is much better than us, to figure this kind of stuff. So what are the kinks of what makes a function impure is that if you use a global variable, so don't do that. And the important thing here, before I pass that, is that as JAX will be very smart in to figure out if you are doing if there is a global or external dependency. It's going to give you a warning. There are sometimes that will let you run. You can fool the JAX interpreter to do this, but it's important that you always think in very small composable things. So in the same as the Unix philosophy, do one thing and do one thing and do one thing right. So just keep in mind from that. Also, JAX, apart from the states, it's born about the necessity of replicating results. So for you practitioners out there, I don't know if that has happened to you, but when you try to replicate a result from a very well-known lab, even if you have the compute capability, you cannot manage to have the same results. I had uh, I had I have spent weeks, days afterwards in which trying to replicate neural architecture, even with the same data, to figure out data, and it's difficult. It's very difficult. Sometimes I really think that I need to do a Dr. Faust kind of deal to figure out how they freaking train this kind of architecture. But in JAX, this is going to be solvable because we're going to have a way of exactly replicate the results. And even with there is things like that are random, that they are random, because we're going to figure out how to do this kind of random stuff predictable, which just sounds weird, but bear with me for a few minutes. In comparison, in NumPy, you're going to have this operation, which is going to be random seed, and you set the global seed. And what happened is that every time that this get called, right, is going to change the seed behind scene. So there is a global state shared by all these kind of variables that are using NumPy and this kind of seed. Is that there is a global variable that is changing the value of this kind of thing. So that makes reproducibility hard, right? There is also another theoretical properties that are not well suited for generation of pseudo-random numbers in NumPy. And in JAX, we implement a pseudo-random numerical algorithm, the numerical random generator that has the property that it's safe to share between parallel execution of a program. All right. There is a question that what is the state of object recognition ecosystem? Bear for me 10 minutes, sorry, 5 minutes. I don't have too much of a slides and we're going to get there. And we're going to see what are the models, so bear with me for a few seconds. So long story short, we're going to be able to generate random numbers. We're going to get very good random numbers that can be shared between different instances of a program, and we can reproduce this. And the way that it's going to work is that the user, here is an example of how NumPy, when you call a random integer and you set the seed, you're going to figure out that you're going to see that it's they share state. So if you try to replicate this, it's going to be hard. So in JAX is the responsibility of the user to share this kind of to have this to set the randomness whenever an operation that requires random numbers, and that's good. Of course, it takes a problem that you have to pass all the it takes a problem. Now you have to carry a random key all over the code, but we're going to see there are libraries that take care of this automatically. There is a question of what would you recommend for developers who are not familiar with low-level development or hardware acceleration issues before introducing JAX into the models. What I want to try to explain is that it shouldn't matter what hardware you run. If you have JAX code that runs on your machine, it's going to be able to run on a GPU or on a TPU. So honestly, don't worry if you have no experience. JAX, it's a very good library for you. All right. So as we mentioned in the presentation, we already have two of the things that I want something that takes a function, give me the gradients, I can reproduce results. And now I wanted to make it fast because I feel the need for speed. There is a transformation of a function that is going to cheat, right? So we have something, a code that shares this property, that is a pure function, doesn't have a state, and you call it frequently, you can get it, right? And JAX is going to read that code and generate a optimized code of this function. It will also compute the gradient, and it will also compute a speed version of that function. Oops, sorry. So as you are going to see, the first time that you're going to call the function gret, it's going to take a time for compile it, and then afterwards it's going to be extremely fast to do it. So if you have the time and you want to see the slides, try to do this example in PyTorch or Keras, and you're going to see that there is a significant bump with just this gret compared to other frameworks. So hopefully it will be helpful for you. And there is another one that I don't think there is much time, but it's called bmap. And bmap is I give a function and I want the computer to automatically make this vectorized code. So for those that hope that comes from R, recall that when you write your algorithms in the R language, if they are not vectorized, it's going to take a hell of a long time to do it. And make the code vectorized is extremely hard. And when it's extremely hard, it's almost impossible. So what happened in JAX is that you can give me the function and JAX will automatically make this vectorization for you. No problem, almost for free. There are a few specifications that you have to do in which where you want to optimize, where you want your batch results, but it's completely different like in our language. So if you have algorithms that were developed in R, just give it a try and try to beam up and try to compare this kind of stuff. So I have put a few examples on here that probably when you have the slides, I'm going to share the slides, no worries, you can see for yourself, but it's really cool that you have something that can just read your Python code and just make it fast. So you don't need to put some effort into bring it to C++ or bring it to another language to make your code fast. And what is important for us as machine learning engineers is that these things run fast, and there is properties. There is a framework to deploy this kind of models. So JAX also provided the computation of derivatives, as I told you. So you can give me just the function, and will automatically compute the gradient. Look, just I give you the function, hyperbolic tangent. I can get the gradient and also evaluate at that point. So for us as machine learning engineers, you take the function loss and you just derive, and you don't have to get like gradient tapes in TensorFlow or just or call any other libraries such as PyTorch to compute the gradient of a function. All right. So now, hopefully, to the answer to the YouTube questions is that there is a Scenic. Scenic is a set of library of JAX and Flags library that provides you with the minimal tools to create object detection models. So there is also not only for detection, can be for also object classification, segmentation. There are many. It's a collection of. It's a library that allows you to create your models in JAX. Okay, still a little bit of development, but what I'm going to show you is that you can actually go to the code and understand what they are doing. So let's take a look at one of the layers for the residual layers. And you're going to see that it's extremely simple. So you're going to hear in the next few talks that there's a developer of the Flags and JAX library, which is Christian Garcia, and he actually works on this kind of API. But you're going to see, you just define what is a model, you define that it's a compact, where it's X and Y, and then if it's the real type, just return X and Y. And you're going to see that the composition of this function is extremely easy. If you can put everything into a class or a data class or a model, you're going to see that it's extremely simple and fast to create these kind of neural network layers. There is also a collection provided. How Scenic is structured, you can set the dataset lib, which is based on the TF data. So you are going to get this speed ups automatization by Google to run on TPUs, in CPUs, and the loaders. And the model libs is where you can bring your models, or you can use another kind of another implementation of the models to run your experiments. And most of the loop utilities, train lib, common lib, is already implemented on that. So honestly, it's just bring your data set and run it and choose the architecture that you want. And many projects has been implemented. So I'm going to show you the state of the art. So the vision transformer was developed in Scenic. The OmniNet paper was there. Probably the most cool ones are the poly visual transformer, which that code trains in images, videos, and audio, and also the videos. There is the video classification. So things that were extremely hard with the object detection API in TensorFlow is extremely simple with here. So I just want to show you this JAX and Flex. What is important is that all these projects have in common two things, actually. The first one is that they use JAX and Scenic for doing this kind of inference, but also they have a good, really set annotation of data, and that's also like the most, like probably 90% of my job outside outside of work writing model. Most of the time is me figuring out data issues, data labeling, this kind of stuff, and that's why important to have a partner like LinkAI that have something that have some that knows what are the main issues with this and know what we want as machine learning engineers. So try to find a good partner annotation, and we'll see that making this kind of models, the code is there, and you're going to see that it's um, extremely easy to it's extremely easy to generate your own state-of-the-art object detection and object segmentation. So I think that's me. I think I left for 6 minutes, a little bit more, but hopefully that was helpful. And if you're interested, I'm on Twitter as _David Cardoso, or you can add me on LinkedIn. I'm open to questions, doubts. I might not respond the same day or the same week or even the same month, but I will try to answer everything eventually. I'm eventually responding emails. So hopefully that helps and give you a sense of what is like this kind of new revolutions in large language models and what are the tools that are being used for that. So I think that's it. I will leave my space to the other speaker. So I don't know if if that's okay for you or.
Thanks, David. Well, thank you for that
Mhm.
amazing talk and for the shout out. Thank you for that, David.
Mhm.
Um, well, we had 5 minutes for questions, but I think you got them almost all. We have one. We can
In
take one.
relation to my last question, how much is JAX different from Keras? Because Keras framework takes care of wrapping around tensor graph or non-pure array to make it hardware compatible. Um, you can actually see JAX more closely to TensorFlow because it provides the tool for working with NumPy. If you want to compare Keras, you could have like Flax or Elegy, which are like above JAX, because JAX you implement the layers. I think at some point you're going to see that when you want to push a little bit your object detections or your image segmentations, the Keras API is very, very strongly constrained. So there are a few things that if you don't want to have a sequential model, if you want to have like um a customized loss, it's going to see that the Keras API is actually it's a bit constrained. And what is important is that when you have this kind of issues as a software developer, as a machine learning engineer, is that you can actually jump the abstraction and being able to do whatever you want to do above that abstraction. So with Keras, if you jump outside of Keras, you get TensorFlow, and I'm pretty sure me as a old TensorFlow developer and contributor, developing in raw TensorFlow is not going to be, it's not a fun experience. Instead, my experience with JAX has been that it's extremely simple since I already know NumPy. So if you already know NumPy, you can actually contribute very easily. There are projects like Flax and Scenic, and you're going to see that reading the code is not that hard. It's not mangled like in TensorFlow. So hopefully that helps.
Great. Thank you,
Yeah.
David, for your talk and for answering the questions. I think it was great. It was really interesting, and we are very excited for our next talk. So, thank you, David, for joining us.
With
Welcome,
pleasure.
everyone that is joining us for our second talk of the day. Welcome, welcome, the ones that are still joining us. Well, for the ones who are joining us now, well, this is our first webinar, but we will be having and hosting more. So don't forget to follow us to be tuned for next webinars that we are hosting on AI and computer vision. And welcome, Christian. I'm very excited for this talk as well. I've known Christian for like a lot of years, and I'm very excited because I really admire Christian and his work. So I think you will be very, very excited for this talk. Christian, it's a technology and business strategy expert in machine learning with over 15 years of experience and expertise in the industry. Currently working as a machine learning developer at Coinside. He is also passionate about technology and innovation, which has led him to be prominent speaker in various technology and entrepreneurship events worldwide. And today he will be talking and sharing with us about the deep learning world, a branch of artificial intelligence that allows us computer systems to learn and improve autonomously. And he will be sharing with us the evolution of deep learning and the trends in recent years. And I'm sure you can't wait to see what the future of deep learning looks like. So, welcome, Chris. How are you?
Thanks, Paula, for that amazing intro. I think I would have introduced myself. I could have introduced myself better. Great. I enjoyed David's talk. I feel he stole my topic, uh, but
Yeah.
I'm gonna I'm gonna give a lighter talk to David's. Um, it will be a little bit more of a what is happening if people are new to the ecosystem, but some things like gonna talk a little bit about transformers, which are very hard to ignore right now. So yeah, let's see how it goes.
Okay, so take it from here, Chris. And thank you. Thank you for being with us today and joining us in our first webinar. So, here you go.
Um, how do I activate my? Okay, yeah, there it is. Um, okay, so I think Paula covered this incredibly well. I work as a machine learning engineer at Quansite. These are my social media links if you want to get in touch. I'll also put them at the end. Um, I'm gonna speed this talk a lot because we have like 20 minutes. So I'm just gonna skip over a bunch of stuff and try to get kind of the main idea. Um, okay, yeah, these companies I've worked before, and I do a lot of open source. Okay, so we're gonna talk about deep learning in the 2020s, and I just wanna point out the differences to how you did deep learning, like I don't know, maybe 5 and even 10 years ago. So we're just gonna see a lot of stuff. I've put um, like a lot of new stuff in this intro, but sadly I did this like the field is moving so fast that this is little bit outdated. This was created during the like diffusion models hype, but we're now in the chat GPT hype and LLMs. But I'm gonna give you like a big picture. So let's think how deep learning has evolved in the last 10 years. So uh, 11 years ago now, like there was this big revolution with AlexNet. So what was AlexNet? It was like the first big, not by today's standards, but it was big neural network that was able to crush the like the ImageNet competition, which was I guess you can see the evolution. Now people don't care about this a lot because it's mostly stagnated, but this leap was huge, and that's how we went into this direction. um, and I want to see the evolution, or just try to see like how machine learning models can, if you want to classify them, how could you sort of classify them, not in the traditional like deep learning versus forest, just in a different way we're seeing now. So I'll say that, like, initially you had a lot of statistical methods, and it was hard to differentiate between uh, like just pure stats and machine learning, uh, which is good because all this is the ultimate statistics. But um, I guess the slight evolution was what, like, I guess the feature, like learned representations, I didn't put it here, but there was a step where these models got to learn some representations, and that's kind of where the deep learning initial revolution got. I say it's inference only because the learning, as well as with the statistical methods, happens uh, only during training. So they are only good for inference, I guess, would be like one way to view it. Or um, another way to view it will be that, yeah, you cannot uh, use them for new tasks. And I think what we are seeing right now is a little bit of a, what you can call, generalizable models. So contrary to the inference only, this you can sort of use them in new ways uh, during testing, or, well, when you're actually using them. And this is what I think sets them apart from, I guess, the previous models. So you could call it deep learning 2.0. I think deep learning 1.5 is kind of good enough, and we'll see why. So, like, the current development process is more like this, or the, yeah, for like the traditional deep learning models. You got some data, you did like a lot of training depending on your task, and then you did inference. So at inferences, these models are, I guess, frozen, but they do kind of their job that they were trained for. Uh, the I think the change that we're seeing now is that you get these models that can um, like do new tasks somehow. Obviously, there's like an asterisk there, without being trained. So they're kind of very general, and you can get to solve your own problem with them without having to do the training part. Obviously, if you train them, um, they are better, but this is a huge step forward in usability. So what is kind of the trick behind all of these, um, like the generalizable models? I think the the essence of everything we're gonna see from here on is that they are good at few shot learning. So what is few shot learning? Um, I mean, it it depends on like what you're doing, but like the general idea I'm showing with images is, um, if you can construct like an embedding space that is like very detailed, such that if you have things that are similar, they should be close in this space, and things that are a little bit different are a little bit more apart in this space. So okay, this seems like just like very simple. What can you do with this? And this is like a very powerful tool that we have right now. I think one of the best models for this, at least for images and text in combination, is Clip. So what is Clip? It has a text encoder and an image encoder, and what it tells you is sort of it gives you an embedding for a text and an embedding for an image. So you can think like an embedding like as a point in this in a space, whatever that is. What Clip does very well is that if you have two similar texts, it will produce a similar embedding or a, a point in that space that is close by between them. And the same for images. And the biggest feature is that this space is shared between text and images. So if you put two images that are similar, they should be close. But also if you put a text that has the description of an image, they should also be close. So if you put like, let's see some examples. This is like a thing you can do on Hugging Face very easily, just testing Clip. So what do we have? I put like picture of a puppy, picture of a dog, picture of a cat. Um, so I put this and I put and and then it gives you okay to this image like how what is the sort of, let's call it probability, if you kind of try to uh, interpret it as that of each of these phrases corresponding to this image. And we see here that a picture of a puppy is the best one. I put picture of a dog just kind of to try to trick it because obviously puppies are dogs, and you see that it has probability but less, so that is very good. And elephant and cat, they get zero, so this is very nice. uh, so you can basically create a classifier from text without having to train a model, and this is huge uh, because it makes using deep learning very easy. uh, this also works in NLP, so let's see how well. I think by now everybody has used ChatGPT, so like this trick is probably um, well known by a lot of the viewers. But how does that work? In NLP, the thing is okay. These transformers are trained just to predict the next word. So you have a next word, and you just try to predict one by one, given the previous ones. And it sounds very simple. So this is exactly what you've seen from autocomplete from like Google for a lot of years. So okay, how is just predicting the next word um, like zero shot learning? So the trick that was discovered in the GPT-3 paper was that if these models, just by looking at all, basically the entire internet, uh, if they just learn to predict the next word, you can trick them into predicting the answer to a task. So what could that be? So let's say you say translate from English to French, and if it's seen a lot of uh, like this is in English and this is in French data that says like uh, this phrase is like this in English, it is in French from whatever. It or maybe it just generalizes because it understands the concept of each language. Um, you can trick it, and if like this kind of thing is within its training data, it might just produce like the answer. So this is zero shot. So you just say, okay, what would be like the word of cheese in French? There's also like one shot, uh, which is you just give it an example. So you say, okay, this is a task, this is one example, and maybe from the example it tries to see what you want to do, and then it just kind of following a pattern, it you hope that it will produce the answer. And then few shot is just the same, but you give it more examples. So uh, obviously we now know that this can work really well. So with a ChatGPT 3 paper, it was something that came out as really nice. Like, okay, maybe I can train a sentiment analysis just by giving it a couple of uh, a tweet and sentiment, tweet sentiment, and then new tweet, and just put an arrow and hope that it produces the correct sentiment. So that was great, but we've advanced. So um, so what do we have right now? So the next huge step was ChatGPT, and well, like I mean, GPT-4 came out yesterday, or I mean, this week. So it's been very crazy. What is the trick? Obviously, more data, bigger models, blah blah blah. But I think the main difference that we see right now is that they do some additional steps. The first one is that they actually train on samples of what they call instructions. So instructions could be like this. This is kind of an instruction, and they collected data sets of instructions, and then they tune on that. So maybe the model is a little bit more geared towards solving tasks that the users put. Then they do a two-step process that is known as reinforcement learning from human feedback. So very high level. They have humans try to like rate the outputs of the model. So they give it like a prompt, like an input. So like a question, or like uh, do something for me, and then they rank the different outputs. So it can produce, let's say, 5 outputs, and humans say which one is better. With this, they collect a lot of data from humans, and they train a model that tries to predict how the human would rate the output. That is that is kind of a reward model. And since you have a reward model, that's when reinforcement learning comes. And then the last step is, okay, just leave the model producing from tasks, producing like outputs. And now you don't need humans because you have the model. So they use the model as a proxy for the humans, and that way they can scale it up to like thousands or millions of task examples, and that is basically reinforcement learning from human feedback. And I'm not gonna put examples of ChatGPT. I mean, I think by now most people know that it's incredibly powerful. Probably GPT-4, once we get access to it, will be. I mean, people are talking about AGI because of this, so that's kind of enough. We've also had like a revolution in generative models. Let's skip a little bit through this, but I mean the big change is that we are getting really good at producing images from text. So stuff like Stable Diffusion, DALI 2, Imagen, and now we got ControlNet, which I didn't put it here. So we can produce beautiful art. Um, like this is just amazing. I think this is probably Mid Journey. Diffusion smalls, just gonna yeah, they work by iteratively converting noise into an image. Because of time, I'm just gonna skip. And on the transformer side of things, this is outdated. Obviously, put ChatGPT and GPT-4 here, but like there's like a lot of like transformers are obviously the what powers these large language models. Uh, I'm gonna skip a little bit through this. Um I guess the main thing that has powered all of NLP has been the transformer architecture. This image is super iconic, so I just wanted to put it there, but I don't have time to explain it. And so diffusion models are based, LLMs, large language models, they use transformers. Diffusion models use this diffusion process approach that they try to create a model that can iteratively denoise an image, and that has proven to be like key. Obviously they denoise it based on some text, so you can control it, and those two things in combination have produced like a revolution in generative images. And yeah, how to get started. You can get started from scratch using frameworks. I think we are a little bit beyond that for like especially for developers who are not interested in like the machine learning part. But obviously you can get one of these frameworks and you can get some hardware like GPUs and TPUs and train your own models. That's good. But I think recently there's kind of a different way to use deep learning, and it's just using pre-trained models. So I think the go-to is just Hugging Face, go to Hugging Face. They have transformers and diffusers, which contain a lot of pre-trained models, and they also have datasets. Other stuff you can use is like TensorFlow datasets, TensorFlow Hub, Detectron 2, and other repositories for models. That's really good. So things like creating like a automatic classifier, or even we're at the point where you can uh, use like object detection in a very similar fashion, just putting like the labels and it will automatically try to find the boxes that correspond to those text labels. So that is really cool. You can do like a lot of stuff with pre-trained models. So I think for developers and startups, this is the way to go. And yeah, this is just a tiny fraction. And yeah, this is the end. Hopefully I didn't go over the board. Um, and yep, that's it.
Well, thank you, Christian. That was really interesting. I think we have time for one question in the chat. So I'm going to take this one. What is the path I need to follow in order to implement a chat that can answer questions to many linked PDF files?
Ooh, okay, again, a chat to many linked PDF files. Okay, that's kind of a trick question. I think you can do it two ways. I think this presentation is slightly outdated. Like I should have put Hugging Face and then just use APIs. I think APIs are kind of what OpenAI has been strongly pushing for. So, like this question, depending on the length of the PDF, you can try to like put it in the context of maybe ChatGPT or GPT-4 that I think has a greater context length, and then ask questions like you can say like, okay, I have these documents, and literally paste the documents if you have enough tokens in the context, if they're not like incredibly long, and then um and then try to uh, basically like get to solve a task. So this could be like a way. So you would need to put all the documents in the context. There is another thing that I saw recently that is basically trying. You you can also try to get like some document embeddings. I haven't done it myself, but I saw you can try to get like sort of an embedding for each document, and then try to uh, somehow I guess would be, imagine like a summary, and then instead of putting the whole document, put summaries, and if that is somehow useful for like when you start using this language model, they start, it's like if you're programming, so you can get them to do subtasks and then do the final task. So you could do something like get the summary of each one and tell it which one is best to answer the question for the user. It selects one, then you give it the whole document and tell it, okay, now answer the question for the users. There's many tricks you can try. This is very engineering hacky, but there are libraries for this. One library is called LangChain. I don't know if I can write um, LANG chain. Uh, that is one that can help you do this kind of stuff. It's really interesting, and there's a lot of startups trying to use this kind of technologies to create like smart programs. I'd say could be the word.
Yeah, I think we'll be seeing many interesting things months with the new GPT-4 and all the startups working.
Oops. Hello.
So
Mm,
uh,
maybe Paula is freezing. I'm not sure,
yeah,
but
yeah, it's me. Can you hear me now?
yeah, I can hear you. You're okay. You're
Okay.
good.
Yeah, I think it's my internet actually. So I was saying that it's going to be very interesting what comes next in terms of GPT, text, and generative AI. So it's going to be very interesting. I hope Mikael finds a way in the answer of Christian or any other tools that maybe someone can recommend to link those PDF files. And well, thank you, Chris, for your presentation. It was amazing, and I'm really glad to have you here. And we'll be moving next to our next talk.
Bye, everyone.
Thank you. And well, I actually have a great story here. Our next talk is one of my favorites. I think it's very interesting. I used to work for this company. And I met my co founder there actually. And here we really lived and we learned the pain of building training data for AI algorithms. So that's how Linked AI was born. We actually have to collect and label lots of training data. And now I'm really pleased and I'm really excited to have Carlos here. He works at KiwiBot. So if you ever wondered how autonomous delivery robots work and how they see the world, so you are going to be very excited about this next talk. So um, I'm going to be welcoming Carlos. Well, he works at a KiwiBot, as I said before. He leads them. He's a machine learning engineer working in computer vision and teaching KiwiBots how to see our world. So, welcome, Carlos, to our webinar.
Hi, Paula. How you doing? Can you hear me well?
I can hear you. Yeah, good.
Okay.
So,
Yeah.
thanks, Carlos, for joining us, and you can take it from here.
Hi, everyone. Thank you for inviting me to this talk. Yeah, as Paula said, I work as a lead machine learning engineer at KiwiBot. We have been working with linked AI for the last couple of 2 years for our machine learning needs. And yeah, I'm very excited to explain how we are applying machine learning at a real world problem. So I'm going to talk about how we are using machine learning for the specific application of sidewalk delivery robots, and how it is important for us to use these kind of techniques. So I will talk a little bit about KiwiBot for the persons or that are not aware of our company. I will talk about a little bit of the self-driving problem on delivery robots, a little bit of the approaches that are present for solving this problem in the autonomous vehicles landscape. Then I will talk about our autonomy stack, how are we solving this problem, and then we are going to dive deep on the machine learning that we're using, especially for perception, and our data engine that we're using to improve constantly our models, and with the help of linked AI, of course. Um, so yeah, KiwiBot, it's we're a startup that we are doing last mile delivery of goods with these cute robots. We have been doing this for the past 5 years. It has been a good journey. Like this is our fourth version of the robot. We have been iterating both the hardware, the software, different kind of things to get at the point where we are right now. We are right now primarily focused on the United States for delivering food on university campuses. So right now we're working in more than 30, 30 university campuses across the US. We have a fleet of more than 500 robots, um, and and that's our main focus. Right now, we also have plans expanding the business to other countries. We have a couple of demos that we're doing in other countries that also involve delivery, also in for example, in cities, not just campuses, and also some indoor spaces like shopping malls and that kind of stuff. But right now, the main problem is navigating outside in urban areas where where the environment is kind of messy and there are not a lot of rules to follow. So what's the problem? So I will ask you to imagine how normally you walk to get to an address, right? You normally use, for example, Google Maps, and you need to look where you are, and the application will tell you where to go, which route to go, which path to go. And having that in mind, then you will just walk, and with your senses, you will try to follow the sidewalk and avoid pedestrians or bicycles, cars, and that kind of stuff. So the robot needs to do the same, right? The nodes needs to uh, needs to know where it's located. Which is the route to the goal, like which sidewalk or which roads it needs to follow. It also needs to know how to stay on the sidewalk, right? Not being able to fall off the street. Also avoid other dynamic objects like persons, other robots, maybe dogs, and so on. Another important part is how do you cross the street and when to cross the street. That's also a very challenging problem for the robot that we humans do very easily, like with the help of traffic lights and with our vision. And once we know when to cross, how to cross the street, and how to get to the other side of the sidewalk, right? So this is a view of our main frontal camera, um, and 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 you see like this like you see the perspective of the robot and what is the robot is seeing for this kind of particular task. Um, I forgot to mention, like our robots are based mainly on vision. So we have a couple of cameras on the front, some cameras on the sides, and another camera on the rear part of the robot. And we also have some support sensors, LiDAR-based sensors for also for detecting some obstacles. So yeah, so how normally the academy and the industry tackle these kind of problems. So so we have commonly two approaches. One is an approach using a modular system where you have different systems that are taking care of different parts of the whole process, right? So we have a perception system that it takes the sensors, right, and produces a representation that the robot can take to avoid the dangers or the dynamic objects, right? We also have a localization system. It depends on the application. If it's an indoors application, it can be using a map of the indoor space, or if it's outdoors, it can use also an HD map or using GPS. You also have like a behavior prediction module where you want to predict where other actors of the environments will be in the future, so you can avoid collisions. And you have a path planning and motion control. Path planning is to plan where the robot needs to go, and a motion control is is a more level control to control the wheels, in this case of the car, to be able to follow the path. And we have another approach that it's called end-to-end, where you just have a system, typically a machine learning based system, where the inputs are the sensors and the output is just the commands that need to go to the motors of the robot to steer the vehicle. So yeah, in the academy, both approaches have been explored. Also in the industry, NVIDIA have a couple of papers doing this end-to-end system, where they use only images to steer the robot, to steer the car in that case. And also you have modular system like system that a lot of self-driving vehicle companies like Tesla has. It has modular systems that do some stuff. And also with the boom of machine learning, this term software 2.0 was brought by Andrew Karpathy, the ex-former lead of machine learning at Tesla, where the software 1.0 is the traditional programming, right? Where you just code in Python, C++, whatever language programming language, and you have software 2.0, where it's based on optimization or in a training technique, where you just train a system to do a task, right? So the autonomy stack has both things. As in Tesla, we also have that we have it like this, where we have like traditional code, and we have some code that is based on 2.0 code, like it's neural networks that do some work. And yeah, as the program complexity grows, for example, detecting things on a video, programming that like by hand, it's very complex. So normally you use machine learning for solving that tasks that are complex. So our autonomy stack, it's based on a bunch of components, as I already told you. So we are using a modular system, right? So we have a positioning system or a localization system. So we know where the robot, where it is at the world, right? So we are based on a GPS system that has very good accuracy. Like we have sub centimeter level accuracy. So we know where exactly the robot is on the real world, right? So then we have a perception stack that we use the sensors to be able to get information of the environment, to be able to do tasks like follow the sidewalk, not crashing with people, uh, seats, dogs, and so on. We also have a planning stack that it's in charge of planning around the route to avoid things, and we have a control that needs to follow this planning to steer the robot physically. So obviously the machine learning part of this autonomy stack is the perception, right? Because it's the most complex one to code. You just have a lot of information coming from the cameras that are raw pixels, and you need to process them in a way that the robot can understand where different things are and how to use that information for planning and control. So what are we using right now for perception? So we're using object detection to detect different things on the environment, like cars, people, bicycles, motorbicycles, dogs, and so on. We're also using traffic lights detection. So we are detecting the different traffic lights, whether it is a car traffic light or a pedestrian traffic light, and also the state of the traffic light, so we can make decisions on the corners of the sidewalks. And as you know, like there are a lot of open source models, but sometimes they don't work very well from the perspective of our robots. So we need to label them. So yes, for the past years, we have been using linked AI to label this kind of data. Can you see the slide? It's not loading. Weird. Sorry, some technical problems with this slide. Okay, we're back. So we also have a semantic segmentation network. So we can segment all the pixels of the image to know where the robot can and cannot go, right? So this is primarily used for keeping the robot on the sidewalk. So we're segmenting the sidewalk and other stuff. So, for example, this is a video of the segmentation that we're working here in Medellin, where we're segmenting the sidewalk, and the robot can follow the sidewalk and is able to stay on the sidewalk. And this has been a long process that I will talk about it a little bit next. And the other project that we're working on is position and velocity tracking of dynamic objects like cars and people. This is especially useful for crossing the street and knowing when it is safe to cross, and also a motion prediction module to know where the things are gonna be, so we can also plan ahead and make more wise decisions. And of course, all of this needs a lot of labeling. So we have been working with linked AI, and mostly in this problem, we have been data quality for these kind of systems are very important. So we work with them very hard, iterating over the labeling policies, because they tend to change a little bit over the month. And yeah, we have been using linked AI to constantly iterate the labeling process and improve our models. Yeah, so we have a data engine to be able to continuously improve our models. So the typically workflow is this one. We have a database with labeled data. So yeah, we train a model or some models, then we deploy them to the robot, to the operations. The operations will use these models, but as you know, these models are not 100% perfect, so they will do some mistakes. We catch those mistakes. For example, this one, at the beginning, we weren't able to detect sidewalks that were this kind of wet at night. So we were able to identify some of those scenarios. We store them in like we detect those problems, we store them, and with this new data, we need to label them and add it back to the database so we can improve the models, right? So in this part, of course, linked AI have been also very important for us. We also have been using active learning to improve the model. I will explain what it is. It's the same workflow, right? Where we have models trained on a database, then they are deployed. Some problems are triggered, right? And we have a huge database of possible failure scenarios, right? But labeling is expensive, right? And we need to subsample a part of those videos to get labeled, because we cannot label all the videos because it will be so expensive. So we need to pick the most hard videos. For that, we use the prediction of the already trained models to subsample the data. That is called active learning, because we are using the model also to sample the data. And we're also using a self-supervised train model on all of our data. We're using that to get some sort of embeddings of the videos, and to be able to sample very diverse data. So the embeddings is like a summarization of the video, and we can use that to sample more diverse data. And we are using also the predictions or the model entropy with embeddings to sample like a more diverse data and the most difficult examples. And then we label the database using linked AI. And right now we are in a process of automating these things. The whole workflow, it's going to be automated. In order to do that, we also need linked AI because it's an important part of the workflow. And so we have been working with them and with their APIs, so we can automate the whole process, and so we can use their APIs and their notification mechanisms in our system, so we can improve the model continuously without human intervention using this kind of workflow. Yeah, that's everything I wanted to talk about. So I don't know if you have some questions.
Hey, thank you, Carlos, for your talk and for the shout out. Well, I think we have time for one question. So I have one here. How do you manage OOD data and model performance degradation from tracking it to fixing it?
Sure. Yeah. So this data engine have been proving to be very useful because we can track in real time this kind of auto distribution data. Um, so like we know, like we have constantly data coming to the system where the models are not performing that well. So we track it that way. Right now we have a manual curation team that curates these kind of problems and filters the ones that are really causing problems to the models, and then we just then relabel that and and retrain the system to fix it. Uh, I didn't talk about for example, the data sets that we're using. We also have, like normally in the academy, you have like a fixed test set, right? To know what's the accuracy of the model. We have different test sets that are based on scenarios. For example, we have a test set of rainy scenarios, so we know that the models are that we train are improving on upon these different scenarios, and so on. We can track different kind of metrics using different test sets based on these scenarios.
Great. I think we have time for one more. We have one more. So what happens if, for example, water falls on the camera sensor? Does the robot have the ability to navigate under these conditions?
Yeah, yeah, that's like water and snow. It's it
Those
has
are
been a problem for the robots, um, especially when those conditions are present in the environment. Um, for fortune, like the design of the robot allows to the cameras to be covered, so the lens usually don't get that wet. So we haven't had that kind of scenarios with the lenses. More we have been having problems, but with the environment because the sidewalks get wet. But that was solved using this data engine.
great. Thank you, Carlos. I'm really excited and I'm really happy to see how big KiwiBot has grown since I left. And it's been like a whole journey working on these amazing AI algorithms to make to make better the navigation for KiwiBot on sidewalks. So thank you for joining us. Thank you for being here and for answering our questions. And I'll be welcoming our next speaker. Thank you. So we have our third speaker today, and I will be introducing Adonai Bera. He it's a machine learning engineer. He has been working in various companies. He has been software developer, AI leader, and CTO of many companies, which has given him a vision of creating AI products with a customer focus and a global scale. So, in addition to this, he is author of courses such as Professional Neural Networks course with TensorFlow and Professional Computer Vision course with TensorFlow on Platzi. So you can go find him there. And I'm very happy to have him here join us. He's a very good friend from years ago. We have worked together as well in some projects. So thank you, Adonai, for joining us. I'm really happy to have you here today.
Perfect. Thank you, Paula. Thank you for inviting me. I am really happy to be here as well and to share some of the experience that we got in all of the time. Of course, we are learning every day, but it's very good to share some of that experience.
Sure. So you can take it from here. We have 5 minutes of questions at the end, so you can write your questions in the chat, and we'll be answering them at the end of the talk. So thank you, Adonai. You can take it from here.
Perfect. I am sharing my screen. Can you see it? I think yes. I think that yes. Okay, we already see many applications like JAX, many of the new algorithms that are on production, and we saw as well the KiwiBot solution. But now I would like to show you jump from zero to production. And when I say zero, it's mean like maybe you have an idea, maybe it's a scratch, or maybe you find a problem and you want to create that product and you want to put it on production. It's gonna be so hard in just 20 minutes go from the problem to scale it, but I'm gonna try to do my best. I'm an engineer. Right now I'm working in Subterra. Subterra is a company that digitizes the world underground using AI. It's like Google Earth, but for all the things that are underground. And we use too much AI algorithm to do that. But today I'm gonna explain you know about Subterra. I'm gonna explain you how to develop product from zero to production. And I would like to start with something that for me it's important, and it's why artificial intelligence. And I know that you know many AI algorithms or GAN's algorithm in this case, but I would like to tell you the story of this boy. He's 6 years old, and right now he's I think 74, and it's so hard to try to remember him when he was just a child. But suddenly an AI appears, and now you can take a picture and you can create a video with that and replicate that behavior that maybe he has when he was young. And this is one of the solution. I know that with Christian we saw some of them, but it's amazing. Like AI, it's a tool that actually can change the world. And I always want to start with this because it's so important. And I would like to say it like my purpose is how we can make this technology easy to use, accessible, and with good quality to anybody. Like how we can democratize. Oh my God, that word, the AI to everybody. And now that we jump to why I'm doing this, I would like to start with something that everyone has to start. That is the problem. And I would like to say something that I learned a couple of years ago, and was AI is not always the solution. I know that sounds great when you try to sell a product and you say, we use artificial intelligence to do that and that. That sounds very good, but you have to remember always that AI it's not the best, it's not the solution for all the problems. Sometimes you can solve the problem with something easier, or maybe with an algorithm without using a deep learning algorithm. And if you try to first find the problem or identify the problem, it's going to be better when you are going to create the product. And something that happened a couple of years ago, we create a product, we use AI, we create amazing things, but then the problem that we try to solve, it wasn't a real problem. That's why everything starts with the problem. How we can solve it is going to be next in the scope, but for now you have to focus in the problem. What is the current situation? If maybe there is other companies that are trying to solve that problem, and of course the most important thing, how I can talk with the client, how I can speak, or how can I share my ideas with the client and get feedbacks for them. And I think that that's very, very important. And if we do this step wrong, all the other steps is gonna be not like with the best solution, with the best quality. And I'm gonna tell you this journey, like going from problem to production, but I will tell you at the same time a real application. In this case, I'm gonna tell you application that is in a physical store. It's a company that want to understand the behavior of the customer in the physical store. It's like Google Analytics, but for the physical places. And something that they find, and the reason that they decided to do it was because 82 like the people that are in the place doesn't have a good services. And the reason why they don't have a good quality services is because the company or the store doesn't understand the customers. And if we don't understand the customers, we are going to give a bad quality services. That's why with this algorithm, we are going to try to understand the customer, how they move, what is it, how much time they spend in each of the places, how they move to the in the physical store, what kind of product they buy, all of these metric that we can use to improve our products or to maybe create a new one. That was like one of the problems that we found. And if we saw some of the numbers, I'm sorry to go like very fast, but we just have 20 minutes. uh, in Colombia there are more than 290,000 retail company, and I'm spending or are moving more or less 27 billions of 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 pesos colombianos. And it's crazy. We found something interesting. I know maybe AI is not the only solution, there are other ways to do it, but we decided to do it with AI. And like I said before, I'm gonna stop here just 1 second, because if we take the time to create a good problem, or we find a good problem, everything is gonna be better in the next steps. And I love this phrase. It was from Yuri, one of the founder of Waze, and is fell in love with the problem, not the solution. AI it's cool. AI is super cool. ChatGPT 3 it's cool. ChatGPT 4 it's much better than that cool. It's like crazy. But don't think in that tools. Think in the real problem. Now that we have the problem, we understand the problem, we speak with the client, we have to create like the first version and create the scope, talking about team, talking about resources, talking about functionalities. And you have to split your functionalities in the thing that the product must have. And when I say must have, it's something like, if this thing the product doesn't have it, it's not gonna work like we are expecting. The should have is something that it's fine, like it can contribute to the goal, but if it's not, it's okay. And the nice to have is something that, of course, if it's there, it's good. If it's not, it's fine as well, because maybe it's gonna be a small functionality that's gonna make pretty the dashboard, but if it's not pretty, it's gonna still working. Like, these kind of functionality are important, but if we want to develop from the problem from to production, we have to move fast, and we can do that later. And if we focus on the must have, it's gonna be like a version that you can prototype in a shorter time. And this is very and so important. One recommendation that I can give you right now is try to create the MVP, or the minimum viable product. And this MVP, it's like, if you want to create a time machine, I always explain this example. Don't wait to have everything ready. try to develop a first version, talk with the customer, get some feedbacks, and improve the quality of this version. And that's going to help you to, of course, reduce costs, like make it cheaper, fail fast. That is, maybe this is not the real solution for that problem. And of course, iterate. And I think it's so important. Iterate. If this thing doesn't work, how can I change it and make it that works with some new functionalities? Okay, in our case, remember that we are doing like all the journey in short time, and we are doing a case of use. In this case, the case of use of the retail company was, okay, let's connect with the cameras. Let's take the video of the cameras. When I say cameras, it's the camera that are in the place, in the malls, in the physical store, all of these cameras that are already in there, how we can take the video, the streaming, process that video, and give metrics to our customers in a simple way. That was the thing that we would like to do in the first iteration. Connect the algorithm to the cameras and get data about the customer. And start the first problem. Or let's say no problem, let's say the first thing that you should do. And it's, how can I get the data? There are many ways to do it. One of that, there are some recommendations, Kaggle, Google Dataset. You can create your own data. You can use data from maybe the government. You can apply web scraping. This is just like an ideas if you are creating the product, how you can get the data. You can create synthetic data. Maybe you don't have the real, but you can use some synthetic data, or maybe you have a small, let's say, a couple of images, let's say 1,000 images, and you can like increase this data set and have a better data set. Or maybe the customer can give you the data. That can happen, but it's so important that you understand where you are gonna get the data and the quality of this data, because you have to make all like a step of this process. And when you have the data, you have to see the quality of the data. Sometimes we take the data and put it to the model and just expect have the best model in the world, and the thing doesn't work like that. You have to create like a pipeline or a step of the thing that you have to do. One of the first thing, understand the data, clean the data, labeling the data, make some data augmentation. This is just a recommendation. And then which format you are going to need to put it on production. In our case of use, we use TensorFlow, but you can use, as Christian said before, you can use, or as David said before, you can use whatever, PyTorch, JAX, whatever tool that you feel more comfortable. I would like to say something here, because labeling the data, it's really hard, and you have to do it manually. Sometimes you have to do like a semi-supervised labeling, but the important thing here is the tool that you use to labeling the data. Try to find a good one. Okay, can you hear me? Yes, I think, can you hear me? I don't know if there is a way that you can confirm that you can hear me. Yeah, okay, perfect. Nice. And it's so important that you find a tool that you can use, and you can put all the data, and you can trust that you are going to have a good labeling. Of course, you have to do the labeling, but the good thing is that you can iterate in different formats. Like if you want to use Coco dataset, or if you want to use TF records, or if you want to use the CSV, the JSON file, you can iterate in that different formats. And in the same time, you have a good quality on the labeling process, and a good, let's say, tools to make a easier or a faster labeling process. This is some recommendation. I know that we can go deep in all of these steps, and it's gonna be like a talk for all of them. But if you want, we can talk that in the question, or maybe in the future you can send me a message and we can discuss some of the specific recommendation on all of these steps. In our case, we use the security cameras. We get the video from the cameras. We use the camera that they already have and we retrain the models with that cameras. I am talking about the cameras that are in the physical store. And the good thing here is that we keep collecting data to retrain the models. Sometimes the customer give us too much data, but then if you want to improve the model, maybe they just give you a batch of data, but they don't give you this data like every month or every week. You have to think in the future how you can keep collecting the data, and this is so important. Okay, let's move to create the models. I'm gonna stop here because we already talked about the problem. We find a good problem. Then we go to the scope. We create times. Let's say times. We create the most important thing in the project, and then we jump to the data. We saw some of the data that we can get, where we can get this data, and now we are in one of the first things that you have to do, that is create the models. But as Christian said before, we have many different models right now, but you have to think in your project and maybe ask this kind of question. Do I need a process that is real time? Like this process has to work in a real situation, 24 hours, giving me the response of the prediction in real time? Because if the answer is yes, you have to find a model that is good in accuracy, but in the same time is not really big because you can't put it on production. The other thing is the output. Sometimes, and I remember a friend that he created a model to detect or to find with an object detection algorithm anomalies in plants. But if he implement or if he create an object detection algorithm, it's going to be different if he create a segmentation algorithm or if maybe he use a panoptic segmentation algorithm. And that different type of algorithm depends on the project. If you are going to make something that doesn't have to be the accuracy, at least it don't have to be like very pixel by pixel. You can use an object detection algorithm and keep getting good results. The accuracy, it's totally different if I create a system that can detect cancer, and if it fails, the algorithm is gonna be horrible, or if I create a system that maybe is just using the data to a recommendation system or something like that. And there are other steps that I have to jump because I don't have enough time, but resources, quality of the data. Sometimes we want to create an amazing model, but the data that we have is not good enough. And you have to think in which model you use depends on the quality and the size of the data, complexity, and of course, what are the last research, and keep changing the models and iterating in new models. I remember that I tried YOLO version 3 a couple of years ago, and then now it's like YOLO version 8, and it's moving fast, and there are another object detection algorithms that are better. And yeah, you have to keep looking the latest research and try to get in that specific versions that works for your project. And now we have the data. Now we talk about how to find the models, and you can create the first iteration. And the first iteration in this case was a model that only detect people. It's something that we know in many places. It's like an algorithm, pre-training algorithm that works really good. It's like something that is easy to use. You have to download, put it on your computer, and it works. But this is just the computer vision algorithm. Same with behavior, maybe create heat maps to get some information about how these people move in the place, and with that information show to the client. Or maybe algorithm to detect if it's a man, if it's a woman, maybe how long, like if it's a boy or if it's a young man or if it's maybe an old man. This kind of information you can use it as well. That was the test of case of use of the algorithm of the program that I am talking about right now. And something important that I would like to share is that you have to be open in case of everything change. You can keep contributing, or the project that you create, the solution that you create, keep working in this kind of scenarios. I remember when COVID started, everyone has to use mask, and now how we can detect if it's a man or if it's a woman, it was so hard. But if we have the knowledge and we are ready to iterate, you can apply a different algorithm that use another kind of information to detect if it's a man or if it's a woman. These kind of change are the change that I would like to suggest to you. Like, be open if you have to change the main goal of the product or some algorithm, but keep working in the main goal of the product. Okay, we are almost there. Yeah, you have the product, you have the data set, you have everything. Now you have to put this product in a real situation. Like, put this in a real store and see how this works. If maybe it's working good, what kind of things you can like improve of this algorithm, and in the same time, which other functionality you can, what other functionality you can create using this technology. In our case, we tested in a small physical store in Bucaramanga. I am from Bucaramanga, Colombia, and it works it works good, and that was like the first iteration. And when we showed this, the customer give us like 100 of feedbacks, and at that moment you have two options. The first one is to start to do all the feedback that they give you. That usually is like 100 of them, like they always give you feedbacks, or you can create a roadmap. This is a recommendation. If you are creating a product, you can create a roadmap and start to put the functionality that they tell you, because it's important, it's the customer, but taking account the priority and the value that this functionality can generate for the company or for the product. And if you do that, you are going to have a roadmap, and maybe you are going to put these new functionalities in a next version. But you can like you can keep iterating in this first version and just using like the minimal or the minimum functionality that you need for this application. And yeah, they give you feedbacks, a lot of feedback we receive. The important thing here is that all of the feedback that they give you, you can use it to improve the quality of your model. In our case, they ask to maybe create the reports, maybe create some metadata that they can use, times, what is the time that there are more people, and another kind of metric that they want to have. And then in that moment, you create like this was a gift, but it didn't work. You create like a retail laboratory. In this case, in your project, doesn't matter which is your project, you have to create a way. I say laboratory because I like this word. You have to create a way that you can change and you can improve the algorithms, working with the customer, like very close, and making change, improving the product, and of course always trying to contribute and to solve the real problem. Okay, and then you are very happy because you have your product, you already tested, works good, but now you have to deploy it. And yes, you create a machine learning algorithm. You use a pre-trained model in this case, but now you only have a small portion of the code. Now you have to think how can I put this or all of this algorithm in production. You have to think in service infrastructure, in configuration, feature extraction, all of these steps that are next to the machine learning code. This is one example. This is in GCP, and as you can see here, for example, you have the security cameras, you have a client router, and you send the video. The video is here using, of course, some servers. We stream the video. I am not gonna talk in all the detail of this example, but you start to get the data and you start to create all the infrastructure that can support a machine learning model. And of course, that is something really hard. Keep spending less money. Like if you put AI algorithm to read or to make prediction in a real time, 24 hours, 7 days per week, it's gonna be so expensive. That's why you have to think all of these scenarios and try to find the best way to put your product on production. There are many ways to do it. You can use the cloud, Google Cloud, GCP, AWS, wherever you want to put it on the cloud. You can use embedding system that is gonna be something like, let's say, a small computer where you can put the algorithm, and maybe that's gonna be an example. In like instead of put it on the cloud, you can put it on the camera that is on the place, and then you can get and process all the data in the same place, like in the loop. Or maybe you can put your computer, like a local computer, and run the algorithms there. Or you can use another kind of thing that is USB accelerators. You use your computer, you put the accelerator, the matrix computational things are running on the in this accelerator, and you can use a normal computer and keep working in very good and in, let's say, good quality models. This is like my two slides. And when you put this model in production, let's say we use the cloud, we develop everything on production, we are ready, we are getting data, you don't have to stop. You have to keep working on that because the model have a lifetime. Usually, you develop the product that create a business value, but then the time is gonna be different. Like a lemon is gonna start to maybe don't generate the same value, and you have to be improving and working in these models to try to keep contributing to the main goal of the product. Usually, the product that you deploy today is not going to be the same that you're going to use in the next year. As Charlie said before, they are retraining the models, like not every day, but they are retraining the model with new data because the ecosystem, the environment is moving so fast, and you have to keep using the best quality and the best models. That's why it's something that you have to keep looking and to keep training. This is some of the things that I recommend. It's like my one of the last slides, and it's you have to define metrics. If you are gonna see the performance of your model using the accuracy or maybe the precision of the code or whatever metric you want, you have to think which is gonna be the metric that you can use to measure the the results of the response of the algorithm. Um, because you with these let's say metrics you can create like tools that can track this response. But you're gonna say, yes, I can get the accuracy on the training. How can I get the accuracy on a production algorithm where I don't have the real values? You can use, there are many ways to do it, but at the beginning you can use just like a QA team to check some of the inspection and get some metrics. It's gonna be like the first thing to do is something manual, but it can help a lot. And you can create like a error reporting and handling that is how my model around production we can keep looking if it's working good or if it's working not good. Or you can create like a model, different model that check the quality of the same one or send like a period of time some of let's say objects that you know the class and see how is the performance of the algorithm. This kind of idea is something that you can do to check the quality of the models. And of course, something very important, feedback. You have to show this to the expert and actually each week, each month, trying to get feedbacks from them and improve the quality of the models. And yeah, I think for now it's everything. I know that I speak so fast sometimes, but it's because we are like with just 20 minutes. But to end, I would like to give you some feedbacks. No, sorry, some recommendation if you want to start here. Um, the first one is be part of the community. If you are in Colombia or in Latin America, you can be part of the TensorFlow community. It's one of the community that are. I know that machine learning algorithm community. I think Christian and David are there. This is another community, but try to be part of this environment and try to know another developers. Um, Take advantage of the programs, get a mentor, make courses. If you want to know more about this, you can get some courses in Platzi, Coursera. This is one of my courses. This is by LinkedIn if you want to scan this. And this is like the meetup of TensorFlow if you want to join us. We have a meeting in 1 week, 2 weeks that is going to be in Bogota in Google office, in the Google offices. You can go if you want. And yeah, the best experience working in a startup is going to be like working in a real situation, moving so fast and always learning. To just to close this, thank you so much for listening. I know that it was like something fast. You can connect with me. We can keep talking. Anything you need, I am happy to talk about that. Yes, thank you, Paula.
Thank you, Adonai. Thank you for your presentation. It was really interesting. I think we have time for one question that is in the chat. Daniel asks if you have used embedded systems on analog computing to train machine learning models?
Okay, just 1 second. I can hear you. Can you repeat the question? I think now I can hear you.
Sure. So, uh, so Daniel is asking if you have used embedded systems based on analog computing to train ML models.
Okay. No. I have experience develop. I have to say true. No. The close answer is no. But I have experience develop the inference of the model. Like you train the model maybe in the cloud or maybe in your computer or in whatever tool you want, Google Colab, and then I take the inference model, the model, and put the inference in a Jetson Nano, and that is a embedded system. Um, but train the model in the embedded system, I think I know it's possible, but I don't know if it's the best thing to do it. But yeah, you can create the model, put it in a Jetson Nano usually because very good, the NVIDIA Jetson, and you can make the inference there, Daniel.
Great.
But I like analog computing. No. Yes.
Okay, thank you. Thank you, Adonai. Well, we don't have time for other questions, unfortunately. I promise we would have more time for our speakers next time. Promise. Thank you. It was really interesting. Now we are welcoming our next speaker. Thanks, Adonai, for joining us. Um, and well, before welcoming him, I would like to welcome people that are joining us now. We are very happy to have you here. We are very happy to see so many people joining us through the whole webinar. We have been having really interesting speaker talks today. And well, I just wanted to let you know that we are hosting other webinars soon. So if you want to keep track of our new webinars, and if you want to stay tuned to new webinars and events that we are hosting, you can follow us on LinkedIn or on Instagram, on Twitter. So you can go find us there. And now we are welcoming our next and final speaker. He's Sergio Cruz. So it is my pleasure to introduce Sergio, who will be sharing his expertise on instance segmentation applied for common bean seed phenotyping. And you will have a closer look at computer vision applied to different industries, in this case agriculture. So it's really interesting. We have been going through autonomous robots, and now we go to agriculture. So it's great to have so many different applications using computer vision on different industries. So, at the International Center of Tropical Agriculture, the CIAT, the Common Bean Breeding Program aims to develop new and improved bean varieties that can withstand environmental stressors while maintaining desired yield taste, and grain quality traits. However, post-harvest seed darkening is a common issue that impacts visual quality and consumer preference, so resulting on significant losses for crop value and producers. So Sergio is going to tell us more how they are tackling this big problem in this industry. And I'm very happy to have you join us, Sergio.
Thank you.
So welcome. And yeah, you can take it from here.
Okay, I don't know if my screen is sharing now. Okay, let me change the screen. Okay, so yes, as Paula said, my name is Sergio Andres Cruz. I am an agronomical engineer working here at Cali in the Alliance Biodiversity SIAT, specifically in the common bean breeding program. So yes, the main objective of this presentation is show you an application of deep learning technique to analyze important seed quality traits. So as an introduction, what is common bean? Well, common bean is a crop that is used as a food source, mainly because their seeds and pods are edible. And it's important to mention that those seeds has many health beneficial minerals such as zinc and iron, and those minerals are very important for the human physiology. This crop is important for the income of many people. For example, more than 200 million people in sub-Saharan Africa depends on this crop as a primary source of income. And also is a crop that feeds the world. For example, in some parts of Africa and the Americas, these seeds provides up to 50% and 36% of the total daily calories and proteins. So it's an important crop, a crop for major importance of societal importance. So this important crop has many production constraints. For example, have many pests, diseases, or abiotic factors such as drought, low fertility. Like low fertility of the soil. But fortunately, this crop have a huge genetic diversity. For example, if you see those seeds, all of them are of common bean, but you could see that they have different shape, color, form, size, and this is due because exists a genetic difference between those individuals that arise those differences. But this difference not only limits to the seeds, they also extrapolate to the performance in the field. For example, exist many genotypes that could that could be resistant to many diseases or could tolerate dry soils. So identify those materials with promising traits. It's super important for any breeding program. So here in SIAT, in the bean breeding program, we spent a lot of resources trying to understand the genetic structure of this crop. That, in other words, is trying to identify which genotype present those interesting traits, because those interesting strains or genotypes are the source of the traits that could help us to develop new materials, new genotypes. So how we could achieve this develop of new varieties that could resist those production constraints? Well, the general idea is crossing. That in other words is make an artificial pollinations between the donor or the identified promising genotype and with a recipient or a genotype that presents a good quality seed quality traits or good yield, good taste. And when you cross those both plants, you're going to have a huge number of offspring. So it could look easy, but when you have a huge number of offspring, you have many combinations of those both parents, and you need to identify which of these child carry the interesting trait of the donor, and also to the good qualities of the recipient or the elite genotype. So with this process, we could develop new enhanced breed materials, but it's important that those new varieties meet or achieve the consumer and the producer requirements, such as the yield, the taste, or the grain qualities. Well, in the common bean crop, the grain quality traits are super important, because what do? You have a genotype that is resistant to pests, tolerate the drought, the low fertility, and have a low quality grind, a grind that is crumbled, that is flat, that doesn't meet the consumer requirements. This material is simply useless. So the common bean grain quality traits is of major importance for the breeding process. So what is the grain quality traits? Well, it's a set of traits that describe mainly the seed. For example, the color, the size, the weight, the shape. The cooking time is an important trait of quality, and this trait tells us how quickly the seed gets cooked. So you don't want any bean that lasts too long time for get the cooking point. So it's an important trait. I underscore this trait, that is the volume. Is actually our next challenge for trying to measure or phenotype, as is a specialized word for say measure the volume. Volume is a very interesting trait for us, and we are trying to implement also the machine learning for measure this trait. And the darkening. Well, what is darkening? Naturally, the common bean seeds gets darkened during the aging. For example, if you have a sample of seeds stored at certain time, the color of the coat or the color of the seed changes. For example, here we have two genotypes, two different varieties, and those varieties were stored during 6 months. So this is a picture of the starting point, and this is a picture of the at the end of the 6 months. As you could see, this genotype is susceptible. The color changes very markedly, but exists another genotypes that don't have this trait. So this material, these genotypes are interesting because carry the trait of our interest. But yes, this trait is super important for the new developed varieties that the SIAT is producing. So what we do for measure this trait? Well, in the mechatronics lab here in SIAT, Harold Diaz developed a platform for phenotype or measure the seed quality traits of the beans. This platform is built with a ring of light, a camera, and a scale for measure the weight of the grains, and is enclosed by a material that makes the conditions uniform. So this platform generates or take pictures of this type. So before we process these images, we make some pre-processing steps. So the first pre-processing step is correct or fix the radial distortion that occurs when you have very tiny lenses. You could see that the border of the image is looks like rabbit. So you could, with those boards, estimate certain parameters of the camera for trying to make a correspondence between the real world coordinates with the image coordinates. So for example, here is in a undistorted image, and here we computed with those parameters of the camera a flattened version. Okay, another pre-processing step is trying to estimate certain parameters that could help us to make a conversion between pixels to real world units. For example, know the equivalence of one pixel and in centimeters. So with this board that we know a priori the area and the size of each of those shapes, we could estimate this parameter. And the last correction that we made is we do is a color correction. So it's important to have images that will be that can be compared between them. So in terms of color, we could make a normalization using this color checker that is just a table with different colors, and we know the reference colors of those patches. So we sample the color checker that is this table, and we try to make a model that could fit the reference colors versus the observed colors. So in this case, we have, for example, here the darker squares are the corrected colors. So for example, here we have the color checked corrected. So now that we have the image pre-processed, we are interested in make a delimitation of each seed. That, in other words, is make a segmentation of each instance. Each instance is each seed, and the delimitation of the silhouette of each seed is named the segmentation. So we need to make an instance segmentation in this type of images. So we try it with an image processing approach that doesn't use any deep learning algorithm and is simply based in some binarizations and some morphological operations for trying to delimitate the sure background and the sure foreground of our image, and also identifying some markers that should be positioned inside of the object of interest, inside of each instance. And exists an algorithm that is named watershed algorithm that could help us to make this segmentation. But this algorithm doesn't perform well because in many cases the markers gets erased, and you need to make a fine tuning of the parameters of each step for get a good results. So we are we make some research and we try to implement one algorithm of deep learning for instance segmentation that is named mask RCNN. So this neural network is an ensemble, is an ensemble that is composed for multiple neural networks. And the objective is that it receives the raw image and produce three different outputs. It produces the mask, a binary mask of each object of interest, and also for each object of interest, this model could predict to which class each object belongs, and also a bounding box that surrounds each object or each instance. So this model is implemented with TensorFlow in Python, and also is implemented in a Facebook library that is named Detectron 2, that is based in PyTorch. So the general idea of this model is that with a pre-trained neural network, this pre-trained neural network computes a feature space that is a complex representation of the raw image. And with this complex representation is the input of another neural network that is a region proposal network that simply identifies which objects or regions of interest exist in the image. And once the regions of interest are identified, they are the input of another two neural networks that are that have the objective or the goal of predict the mask, the class of each one of these rows or regions of interest, and also to delimitate the bounding box. So this model already was tested in agricultural context. For example, here those researchers are interested in segmentate each speck of width and count the number of each grain for make early predictions of or early estimation of yield. So the pipeline of this neural network is first collect the data or the pictures, perform the dataset construction, that is the labeling of each image. This process usually is made manually. And after is the process of training, that we have to train those three networks for make that the the prediction becomes very similar to the annotation that we already do. And this similarity between the two data sets you could measure through the loss function. So this is a graph or a plot of training. In the x-axis is the time or the epochs of the training, and in the loss and in the y-axis is the loss. That is the measure of the similarity between the predicted values and the observed values, the measured. So those are some of the prediction of this model. So we want to try the same concept with the Phenobox seeds, with the pictures of the Phenobox. So we selected a set of 468 images that comes from a very diverse panel of different types of seeds. And we annotated the data using the watershed segmentation that we already mentioned, but we refined manually this segmentation to fix some errors that the segmentation did. So once the training was ended, we tried the neural network with unseen images that doesn't form part of the validation or the training dataset, and we observed a very good performance. For example, here is a picture of the same phenox, and each seed have a different color because the mask that predicted and the bounding box. But the interesting thing is that in different conditions, also the prediction performed well. So now that we can have the mask of each seed in an image, we could make some measurements of grain quality traits. For example, the darkening measurement. So Juan Cantor, he's already made his master degree thesis in the darkening of the common bean. So he developed a setup for accelerate the darkening process using UV light exposition. So for example, here we have an image of two genotypes, of two different genotypes, and 3 replicates in each time. For example, here is 3 replicates at the starting point of the UV light expositions, 24 hours, 48, and 72. And as you could see in this genotype, the change in the color is very, very evident. But in this case, this other genotype, the darkening doesn't occur so evident. So, for example, here is a source of this trait. So, how to measure this quantitatively in a quantitative way? So we have the image. We could segmentate each seed of the beans, and after we analyze each one of the seeds, we use an algorithm that is named a clustering algorithm that is named K-means clustering, that tries to group the color of each pixel in for example, in this case, in five clusters, and we use it a color space that is the LIB color space. This is an important thing because in this color space, the coordinate L tells us the amount of white that a certain color present. So with this coordinate, we could measure this phenomenon of darkening. So we compute a weighted average of the L value for each seed, and we obtain these plots. So in these plots, we have in the x-axis the time of UV exposition, and in the y-axis, we have the average value of the L coordinate. So for example, in the image that I show you before, sorry, you could see that the slope or in the time, you could see the darkening process or the lowering or the decay of the L values. But in the promising genotype, we don't see a pronounced slope. So with this methodology, we could recognize which materials gets darkened rapidly during the UV exposition. So okay, as a conclusion, we say that with this machine learning model, we can measure multiple grain quality traits, not only the darkening, but also we could measure the size, the shape, or well, the volume is a challenge that we have to take. And it's important to analyze that these traits will be or could be very difficult to measure manually, because you have to measure each seed by seed, and the time that you're going to spend analyzing these traits will be very high compared to the machine learning approach. By the other hand, document the grain quality traits is an important process that could help to improve any breeding process, because you could perform selection in an informed way. For example, when you select a certain genotype, you're going to be very sure that present the certain grain quality traits, because you already measured the traits quantitatively. So okay, that was all. So if you have any question, let me know.
Well, thank you, Sergio. That was really interesting. I really loved your presentation. I never thought of it was so much work behind the process of analyzing beans, and so it's really interesting what you're working on. It's really interesting the work that your team is doing in this field, and I think it can be applied for many other like products, right? So could you tell us more like how you could apply, or where you could apply these processes and algorithms that you have developed in other maybe other applications?
Yes, for example, it's an interesting approach for analyze, for example, disease response. So you could have an image of a leaf, and you could measure if that genotype could tolerate a certain inoculation of certain disease, and you could measure rapidly the response of the disease infection.
Nice. That's
Or
really
not only the leaves, the pods. Actually,
yes.
it's just the start, but we want to continue to explore different alternatives for implement
Sure.
this algorithm.
Yeah, I actually think there's so much that you can do with what you've been developed as of right now. And there's so much applications and so much things you can do in the analyzing of agricultural products and plants. So it's really interesting. We have one comment here from Alvaro. So Alvaro's uncle Gerardo Tejada Pombo was one of the first to create a bean variety, and it was a very important development on which other research was based. So he want to know if the Tejada variety still exists. Do you know about that variety?
Yeah, actually, I am the something like new generation of breeders. Maybe we don't have cleared the long history of the old varieties of the common bean, but surely if you are interested, you could contact us and maybe get a more a more specific response.
Thank you. So, well, guys, that's it. That's a wrap for our webinar, our first webinar. So, thank you, Sergio, for joining us. Thank you for your talk. It was really interesting. I loved
Thank you.
having you join us here. And well, thank you all that join us in all of our webinar. We are really excited. We are really happy. I saw many people asking questions and participating, and I'm really glad it was very useful and insightful for you all. So to end, I just want for you to remember that you can follow us for our next webinars, our next events. We will try to keep bringing speakers that can be interesting for you in the computer vision and machine learning field. So feel free if you want to also give a talk in one of our webinars, just let us know and we'll be happy to have you here. So, as I said before, we are celebrating the launch of our new website. So, any feedback and if you can go see our new website, you're welcome. And that's it, guys. Thank you for joining us, and have a great week. Rest of the week. Have a great day, and bye.